All right, I remembered to record today. So we've got that. I have everything that I have recorded up in YouTube. So if anything's not there, it's because it didn't get recorded. Yeah, they're okay. They had a sort of bad health year last year. And then my mom got out of nursing home just before COVID hit, just before they closed everything down. So my sisters have been there quite a lot, and I'm just taking a 2-week stint. They're actually getting a lot better, but my dad took a couple falls and he didn't break anything, but he's like all skinned up and he bleeds a lot because of the blood thinners. So it's just one thing after another. They're both over 90. So yeah. Yeah, there is some progress. So thank you for asking. Okay, so do you guys have questions today? We'll just go ahead and get started and do as many as you want or have, and then we can do anything extra that you want to hear more about that we haven't done yet. We've had another couple days since the test was due to maybe get some things done. Yeah, I know, Dakota. My sister-in-law is out at the Bay Medical Care Facility, and she's been there for almost 2 years now. And my brother used to go every day and stay all day. So now he just can go once in a while. They're doing outdoor visits now. So he gets to go see her, but only for like 30 minutes at a time. Dakota, do you work at the Bay County Medical Care Facility? Oh, okay. Mary Ellen. Oh, cool. Well, tell her I said hello. I got to go to one of the porch visits about a week ago, so I did see her recently. Thank you. Okay, looks like Jasmine is joining. Do you guys have any questions? Oh, yeah, I did say that. I actually said that in one of our earlier emails out as well, but I think with so much happening at the beginning of the semester, you guys were probably a little stressed and may have missed it. So this class is a 6-credit class because it is Math 119A extended hours. So the extended hours means that most likely, if you're in this class, you had a little bit lesser prerequisite skills than in the regular Math 119 that meets only 4 hours per week. So since we have the extra time, I want to try to meet with you guys as much as possible, or as much as you need to, but we've also shifted to an online format. So my thinking is that if you're doing the online work and everything is going well, I'm good with you guys checking in with me once a week, you know, asking whatever questions you have, letting me know everything is okay, and making sure you clarify everything. Remember, you can listen back to any of the recordings. So I'm recording all of the class sessions, and you can listen back to those if you're unable to make it to them, or if you're unable to stay the whole time. So my requirement is that I'm asking you to come at least once per week and then check in with me during that time, just to make sure everything's okay. But I'll be here each Monday, Wednesday, Friday at noon, unless some sort of emergency arises, and then I'll let you know, and we'll just, you know, sort of make it up in Q&A format whenever people need to. You can also pop in on office hours anytime you want, so you don't need an appointment to pop in during those office hours. You just use the office hours Zoom link to go to office hours. And if those times don't work for you, you can't just pop in, but you can send me an email and we can find a time and just meet in Zoom together. So is there anything out there that anybody wants to ask about, check in about? Anything driving you crazy that you need more information on? We did some work on graphing inequalities last time. And 119A, just keeping, yeah, I think we've done a little bit of sort of mini lecture, at least some problem examples on the board for all of the topics for this week. But if there are some problems that are giving you trouble, please do let me know and we can make sure we go over those. Certainly, Megan. Yep, let's start there. Okay, so. I don't want to join audio. Should be okay. All right, that's the board from last time. I never erased it. Okay, so we're going to get rid of this thing. At least get it somewhat out of the way. All right. Maybe. Okay, perfect, Megan. Thanks for giving me an example. Okay, so this problem said graph the equation 6x plus 4y equals 12. And in a problem like this, you've got a couple of options. Some students like to always solve for y and use the slope-intercept form of the equation. Other students like to get the x and y-axis intercepts. So I'll show you both ways and then you can decide, and then maybe we'll try another one and you can try it on your own with your preferred method. Okay, so the slope-intercept method. So in this method, we're going to start the problem off by solving the equation for y. That will let us identify those values for m and b. Remember, the slope-intercept form for the equation was y equals mx plus b. So we're trying to identify that slope and that y-intercept. So to do that, 6x plus 4y equals 12. I'm going to go ahead and subtract 6x from both sides first. So I'm going to do a minus 6x, minus 6x. And just for clarity for myself, I'm going to write the minus 6x term first because that's the way I want it written when I'm done. So 4y equals negative 6x plus 12. And then finally, I'll just divide everything by 4, divide both sides by 4, each term, and I get y equals negative 3/2 x plus 3. Okay, are we good so far? Can you give me an audible yes, Megan, if we're good?
Yes.
Thank you. I either have to jump back across the room or find a way to see the chat. It's just a little bit too tiny. Okay, so we're in the right format, and now once we've solved for y, we're going to graph this using the information from the equation, using m and b. And to do that, let's just put it over here so it's not too low. I always start. We need to start with a point because we've got to place a point down before we can use the slope. So I'm going to start with my y-intercept, which is 3. So y-axis, x-axis, 1, 2, 3. And 0, 3 is that point in question. Then I'm going to use this slope that says I go down 3 over 2, minus 3/2. So the rise is a negative 3, and then to the right 2. Down 3, right 2. And notice that we actually get lucky this time in that we land right on the x-axis. So this one's easier to draw. 1, 2, 3 down, 2 over. I'm landing at the point 2, 0. And then I'm taking those 2 points and playing connect the dots. And there's my nice equation of a line and my nice graph. I could add an extra point if I wanted to make sure that I did this correctly. And if I did that, I would probably go back to my original equation and add my extra point. So for example, I could put in x equals 1 as a test point. Just do a little check by letting x equal 1. 6 times 1 plus 4y equals 12. And that's just a 6, so I'm going to subtract 6 from both sides. 4y equals 6, and divide by 4. Y is 3/2. So I have the point 1, 3/2, 1 comma 3/2. And that looks quite good. That's right here. 1, 1.5, or 3/2. When you're working these in Alta, it's best if you don't try to get coordinates that have decimal or fraction coordinates. So try to go with those that have whole number or integer coordinates, so you're not trying to estimate in a maybe more difficult way. Is that better, Megan?
Yeah, thank you. It's just hard to see the board now.
What'd you say?
It's just kind of a little difficult to see like the bottom of the board.
Okay, and because I have the table, I did not join on my phone. Let's do this. We'll do a little room rearranging. Hopefully I don't trip on something. Let's try to zoom that in, and everything will still be visible, I think, and you should be able to see it if I make it a little bit bigger and a little closer. A little literal zoom. I don't need to be plugged in. Did you pin my video? Let's see.
Yes, I did.
Okay. It's backward. You're seeing it forward though, right? How are you seeing it now? Is that any better? Or no? Let me see. There it is. Let's see if that's better. Is that better?
I think so. It's now not letting me pin it.
Oh, but I just pinned it, so I think it should pin for everyone. I thought. Weird. So that's probably why pinning it is not available. Because I pinned it. I mean, we've got the option of pinning, or I can, no, it's still on Spotlight anyway, so that should be.
If you swipe the screens, you can see it better in another screen.
If you do what?
If you like swipe the screen, I'm on my iPhone, so I don't know if it's the same for everybody on their laptop, but if you go to a different slide, it shows it better.
Okay.
This one looks like it's coming from your laptop.
Yeah, what you're seeing is actually coming from here. I'm going to turn this off so it's completely clear. What you're seeing is coming from my iPad.
For some reason, I can't see the one from your iPad. All I'm seeing right now is your name. And if I tried to pin the video from your iPad, it doesn't let me do it.
Weird. And the
Yeah,
thing
I'm experiencing that too.
Okay, here's what I'm going to do. I'm going to unpin, and then you see if you can pin it. See if that's better.
No, nothing changed.
Weird.
Yeah, no.
It is so bizarre because it on this end, now what happened to me there is, for me, when I unpinned that, then the video went away on my computer. So let's pin it again. Try it now.
There, now I could pin it.
Okay.
Did it.
Bizarre. Okay, all I did was I canceled the Spotlight video. So maybe that was the problem. Can you see it better now that you can pin it?
Yeah.
Okay. And then I think it should all still be up there.
Although the very bottom where you wrote.
I'm gonna angle the.
Okay.
There we go. Now you can't see it all, but at least we've got. You had the first part, and we'll. Scooch it out a little bit. There we go. So it's what, week 3? We'll probably get this sorted out somewhere around week 10. And then we'll only have 5 weeks left. All right, so you gave me this example, and we actually got the X and Y intercept sort of for free on this, but I'm still going to show you that that intercept method, so you can decide which way you like better. Okay. So we're just going to do this problem again. I'm going to erase most of my work, my 2 steps, solving for Y and then graphing using M and B. I'm actually going to leave my picture on the board because we know that that's what it's going to look like. Our work is just going to be a little different. That'll work, kind of. Okay, so slope-intercept method. We're going to take, or our, not slope-intercept method, second method. Intercept method. So in this method, our first step is going to be to find the x and y intercepts. And then we're just going to plot them and graph the line. So either way, it's really two steps that we need to do. And to find those intercepts, remember that we find the x-axis intercept by letting y equal 0. And we find the y-axis intercept by letting x equal 0. Because those points that are intercepts have 0 for one of their coordinates. They have to, or they wouldn't be on an axis. So we just go back to our very original equation. The nice thing here is that we don't have to solve for y, so we're getting that step out of this. 6x plus 4y equals 12. We'll do the x-axis intercept first by letting y equal 0. Some students like to do what I call the cover-up method. If you cover up the y term, it's hard to do from that angle, we'll do it from this angle. If you cover up the y term, notice you get a simpler equation. The reason cover-up works is that when I plug in 0 for y, that term, that y term, goes away. So 6x equals 12, and x equals 2. My x-intercept is 2, 0. And notice that matches what we had on the graph earlier. Then we do the same thing by letting x equal 0. 12. 6 times 0 plus 4 times y is 12. And again, we could do that cover-up method by sort of covering up the 6x. 4 times y is 12, and y is 3. So 0, 3 is my y-axis intercept. And then I would plot those 2 points and connect the dots, and I would be good to go. So, and sometimes some problems are easier to do one way than the other, but some students like to just say, you know what, I'm going to do every problem by the slope-intercept method, or I'm going to just do every problem by this second intercept method. It's sort of a matter of personal preference, which can be problematic. Some students like me to just say, I wish you'd tell me I have to do it this way all the time, but you don't. Okay, so were you guys able to see that all the way through?
Yes. Thank you.
All right, so now we know. Pin the video, but don't spotlight it, it looks like. Is the key. All right, do you guys want to try one? How about if you guys try one, and then we'll I'll turn my camera off up there, and you guys can work on it for a couple minutes, and then I'll turn my camera back on, and we can compare answers. How's that sound? Yes? No? I'm insane? Do you want to go to breakout rooms and work in groups? Yes? No? I'll turn my video back on. All right.
I'll have Friday. It's
What'd you
okay.
say?
I think we all have Friday brain. It's okay.
Okay. Yeah. Yeah. On top of our brains all being kind of messed up from this whole COVID situation, just from, life being so screwed up. Yeah. Okay. So let's try another one and we'll make it very similar to what we just did. Let's go negative 3x plus 7y equals 21. And so I said it out loud, but I also put it in the chat for those of you who want to look at it visually. Negative 3x plus 7y equals 21. So you're going to try to graph that line, and you can use either of the two methods, whatever your favorite one is. could another point be 7, 6? Absolutely, Dakota, yes. Okay, Samantha, I will address that, how she got the -7. In fact, if you peek up at my work now, can you guys see it again? Is it pinned good for you?
Yes, it is.
Okay, notice that I think what Megan did is Megan used the intercept method. So she started probably by letting x equal 0, or maybe she did these in the reverse order. I let x equal 0 first. And when x is 0, remember that first equation should be gone. I should go erase it, and I will. When x is 0, that first term goes away, and we get 7 times y equals 21. So y equals 3. And then if we let y equal 0, we get -3x equals 21. So there's where Megan got her x equals -7. If you used the slope method, the point slope method, you're going to come up with that point. Yes, 3/7 x plus 3 is what you got. That's perfect, Samantha. You just rearranged this equation. So actually, let's get rid of that other one because that's some noise we don't want in there. We've rearranged this equation to get the y by itself. So we add 3x to both sides and get 7y equals 3x plus 21. And then you divided both sides by 7 and got y equals 3/7 x plus 21 divided by 3 is 3. So you started here at your y-intercept of 3, and then probably went up 3 and over 7. And so you landed, at 7, 6. Because you went up 3 from your level of 3 to get you to 6, and then over 7. So if your 2 points that you graphed were 0, 3, and 7, 6, you are also correct. Remember, the line actually represents an infinite number of points. It's all the points along that whole stretch. And so we can't possibly plot them all. And I would be very surprised if I gave a problem on a test that said, graph this using any method you want, if everybody in the class had the same pair of points that they labeled, or even this, especially the same 3 points, because you're going to choose different ways to do this. So if you graphed 0, 3, and 7, 6, then you also have it correct. Notice that this point also fits the slope method. If you think of the 3/7 as, this is kind of a weird way to think of it, but I just want to show you how they sort of mesh together. 3/7 is the same as -3/-7. Now this is kind of ugly, but it can still get us our slope. Down 3 and then back 7. So the rise is negative, which means we go downward. The run is negative, which means we go back to the left. So down 3, back 7 lands me at -7, 0. So those two results are consistent with each other. And it doesn't matter if you give me these 2 points or these 2 points, or maybe even some other random choice of 2 points. It's all the same line, as long as you get points that are along here. Now, if your points ended up down here, there's something amiss. Maybe you have a sign error somewhere or something.
Will
Okay.
the homework kind of be lenient with this or no?
So you know what? Let's go ahead and I'm gonna let me see if I got myself there. I think I do. Let me get into content.
I haven't
And
worked on.
I'm going to share, I'll share my screen in just 1 second so we can look at how this would work in an Alta assignment. So we are just going to share screen. And this one is the one I want. All right, and we're going to do preview because that's going to let me do this like I'm a student. We'll minimize those guys. Okay, so you guys got my screen, right?
Yeah.
Okay, so in this problem, they're just showing us the graph of an equation. And all they want us to do in these is select points that fit. Use the graph to determine which of the ordered pairs is a solution. So a solution is any ordered pair that falls on the line. So let's see if we can do this one. 1, 3 is our first one. And I'm gonna zoom out a little bit just so we can see more of this stuff. 1, 3, yes, that looks good. That's on the line, so I'm gonna check it. Is 0, 1 on the line? No, so I'm gonna leave that one out. 3, -1, no. 2, 0, that looks good. 2, -2, no. And none of the above, obviously not, since we've already checked a couple. And we'll hit submit, and hopefully they don't just give us a bunch of these. Continue. If we get another one of those, oh yeah, this is good because this way you guys can see how this works. So this says graph the line x equals -2. Now this is one of those we talked about on Wednesday, where the line, it's sort of a special kind of line because there's no y equals that we can get in it, which means we can't graph this using the slope. But notice the x value has to be -2. So I'm going to take this point and I'm going to drag its x value back to -2. And I'm going to take this point and I'm going to drag its x value back to -2. Notice the only way to do this is to graph a vertical line. So when you're graphing in here, you're essentially going to grab a couple of points and you're going to plop them in the right spot. If I move this second point up anywhere, I'm still okay because that line is still vertical. If I move it off to the right or left, I'm going to get it wrong. So I want to make sure I keep that line perfectly vertical. And then I can go down below. I could cheat. Now I don't need to cheat because I already put something in. And I'm just going to say submit. And I'm good. And then I'm going to continue and hope I get another one that's a little different. So this was another one of those, which ordered pairs are solution to the equation. I won't do that again. There were 3 of them. We'll submit. And then they just showed you where they plugged them in to make sure they fit. I'm looking for another graphing one. Here we are. So graph the equation y equals x/3 minus 5 by plotting points. So tell me on this one, what's the y-intercept? Can we come up with it?
-5.
-5. So I'm going to take this point that's right here at 0, 0, and I'm just going to drag it down to -5. Now, by plotting points in their book just means, you know, make sure you plot 2 points so that you've got this right. So my second point, I'm going to go ahead though and use the slope method. So what's the slope of this line?
1/3.
1/3. So I need to go from my original point, which was down here at 0, -5. I'm going to go up 1 and over 1, 2, 3. And then it should be good. And if I want to double check, notice this has coordinates 1, 2, 3, 1, 2, 3, 4, 3, -4. And if I plug in 3 for x, I get 3/3 is 1, -5 is -4, so that looks good. I'm happy and ready to submit that, and it tells me I'm right. So that's the kind of problems that you're going to see in here. And here's just another one that's very similar. Let's see if we can get to one that's like the one Megan, it's not letting me cheat. It's kind of rude. I bet it can't do the cheat on these problems, so I have to do this. 2/3 x plus 1, so up to 1, and then I want to go up to over 1, 2, 3, and submit. What kind of line is this? Y equals -9. What does this one look like?
Horizontal.
Horizontal. So drag both of these down to the level where y equals -9, and I'm good, and submit. So no, I don't think they're trying to be tricky here or anything. Here's one. Although this is, again, what ordered pairs are solutions. So let's just cheat. 2 of them worked. I want to find one like the one Megan gave us to start with. Y equals -4x plus 3. So this time I have to go downhill, right? Down 4 over 1. I should be good. Oh, these truly are, looks like all in.
I have a question real quick. How did you know to go over 1 with that last one with it being -4?
Oh, okay. So you know what? This was the slope -4?
Yeah.
Okay. So if the slope is an integer, not a fraction, you
Okay.
can think of it as that number over 1.
Okay.
So
got
for
it.
example, since it was -4, that means down 4 over 1, because -4 is the same as -4 over 1. Notice if you wanted to, you could think of it as -8 over 2, but why make things harder for ourselves, right?
Right.
And it looks like they gave us all of these in slope-intercept form in this section, but maybe not. Let's see, down -1/3, so down 1 and over 3. It looks like I need to scroll up. I think I'm okay. Another horizontal one. And remember, you can check out how you're doing it. At least I can. It's only going to give me horizontal and vertical ones from now on. So I don't think there's much sense in doing more of these. That should be all you have to do in this one. Let's go to the next one and see if it's got, here we are. Here's the ones where you're graphing with intercepts. So let's preview these. So this is more like the one that Megan asked about originally. Graph the equation 3x plus 3y equals -15 using the intercepts. So since they said using the intercepts, you're gonna have to plot the intercepts. And notice they have a little note here. The points cannot be moved off the axes. So that's how they're making us do this. All right, so let's see what happens. When x is 0, what's the y value? Where should we go? 3x plus 3y equals -15.
Is it -5?
It's -5. So I'm going to take that y-axis intercept and I'm going to move it down to -5. I'm halfway there. When y is 0, what's the x value? Is it also -5?
Yes.
Yes. So I'm going to take the x-axis intercept and I'm going to slide it over to -5. And notice I have my 2 intercepts. And I'm going to submit, and I'm happy because I got it right. And then they showed the work. The y-intercept, they let x equal 0. The x-intercept, they let y equal 0. They added a third point just to double check. They listed their points, and then they drew a straight line. Notice their third point, -7, 2, is over here, and it is also on the line. So it looks good. Now this one is kind of interesting because they want us to use the intercepts, but they didn't give it to us in quite as nice of a form for the intercept method. We can still do it. So let's see, if we plug in 0 for x, what do you get for y? Zero for x, the y value is 0 over 2, that's 0, minus 3, -3, so I'm way down here. Now, I can't move the points off the axis, so I can't just go up 1 over 2 using my slope because it's not going to let me take that second point and drag it up or down. I have to just move it across. So I have to get it to the point where the slope is 1/2. Or I can just, let's go ahead and calculate what the intercept is. So go ahead, take this equation, this y equals x over 2 minus 3, and plug in 0 for y and see what you get when you solve for x. I'm going to type that in the chat just in case the verbal info is not the greatest for everyone. So in the chat, we're going to substitute y equals 0 in the equation. Y equals x over 2 minus 3, and then we're going to solve for x. And see what you come up with for your solution for x. So 0 equals x over 2 minus 3. And that means 3 equals x over 2. So x equals what? Hmm.
3 over 2?
Nope. No, I see what you did though. Okay, Jasmine, remember you can come back and watch the rest of the video later once it's up in YouTube too. What number could you divide by 2 to get 3? Or think of it this way, in order to get rid of that 2 in the denominator, you need to multiply both sides by 2. Since x is divided by 2, we want to do the opposite, and 2 times 3 is 6. Let's try it. 6 over 2 is 3, and 3 minus 3 is 0. So our other point is the point 6, 0. There's our x-axis intercept, and we're going to move this x-axis intercept over to 6, 0. Notice now that we have that in place, we can check with our slope. Our slope was 1/2. That means we go up 1 over 2, up 1 over 2, up 1 over 2, and notice we land right on 6, 0. The other way to think of it is to remember that 1/2 is the same as 3 over 6, up 3 over 6. So that's another way to do it. Megan, were you in this section on the homework or were you just in the earlier ones? I'm curious.
I was just in the earlier ones.
Okay. All right. So you really are going to run into problems more like what you asked me about earlier. So that was a good question. And submit and see if we got it right. We got another one right. I'm going to have my homework done. All right. This is, did I change lessons? I must have. Find the slope of a line given 2 points. All right, you guys see if you can come up with the slope of this line. We'll compare answers. 0, -9, and 7, 6. Tiffany, you're fast. Tiffany says 15/7. Does anybody agree? You can use the fraction palette, but you don't have to. You can just use the slash and it'll make a fraction for you automatically. So slope is 15/7. That looks like it's correct. And again, remember they show us all the work, so that's good. I actually want to go back to that other lesson, not the slope of a line lesson. Okay, so then sometimes they give you these to you backward where they graph the line and they ask for the intercepts. So you just have to type them in. Probably the biggest place that you might make a mistake here is by reversing them. So the x-intercept, remember, is where we cross the x-axis. So that's right there. It looks like 1, 0. And you can pull up the palette if you need it. And the y-axis looks like 0, -3. And then we can submit and we're good. And then there's another one. These are pretty straightforward. You do have to estimate on that one, but don't overthink these. On the ones that are fractions, they're usually just going to be halves. So they're fairly straightforward to estimate. Oh, I went back to that one. Keep doing that. Any others that you guys want to look at today? I think we did some good work there. Or would you rather work on homework for a while and then ask questions when you run into more trouble someplace else? Or even here?
Probably the second option.
It's fine with me. It works either way well for me. So if you guys want to take off for today, again, I'll hang out. So if anybody has questions they want to ask, sort of hang around and ask with less people around, I'm glad to do that. So yeah, I'm going to stop my share. I'll actually turn this video back on. I forgot I had muted that video. All right, so you're going to all have a good weekend. Hopefully you won't work too much either on work or homework work. But if you do, at least take a little bit of time for a break for yourself. We got to keep ourselves sane. And otherwise, I will see you all on Monday, noonish. And again, as we said at the beginning of the class, if you can't make it to every class Monday, Wednesday, Friday, it is not mandatory that you come. I want you to go watch watch what we did back. But for the most part, I'll do little mini lessons on things if nobody's asking questions, or I will go over problems that you guys want to go over. So yes, Dakota, you have a good weekend as well. And that goes for everybody. Absolutely, Mateo, not a problem. Can you give me, do you want to just type it into chat? The one whatever you'd like to see?
I could probably just tell it to you.
Okay, that works too. Yep.
All right, so right now I'm on the solving inequality with the unions right now, solving compound inequalities.
Okay, yep.
And my problem is negative x plus 3 is greater than or less than 1.
Okay, I'm gonna go write it on the board so you can make sure I've got the right problem.
All right, thank you.
Negative x plus 3 is, did you say less than or equal to?
Or it's greater than or less than with
Okay, greater than or equal
Yep.
to.
Yep, greater than or equal to, my bad.
That's okay.
And then or 6x plus 4.
Okay, what number goes here? Is that a 1?
It's just a 1. Yep, my bad. And then or 6x plus 4
Okay.
is less than negative 3.
Okay, so the first step is for you to make sure that I have all of that right, because if I don't, there's no sense in moving on.
Yep. It's all correct.
It's all correct. Okay. So what we're going to do is we're going to try to not panic, and we're going to just think of this as 2 separate problems at first. Okay?
Okay.
So we can only solve them one at a time. We're going to look at the left-hand problem. We want to solve for x. What should I do first? If I want to get that x by itself.
Don't you change the x to a 1, right?
Oh, I think, do you mean this? I'm going to grab another pen just because I'm not going to write a separate line. Do you mean thinking of that as negative 1x?
Yep.
Yeah, you can do that. Okay.
All right.
Now what?
And then don't you take away the 1 from the one side and then take away 3 or 1 from the 3?
Okay, I could subtract the 1 and that would give me a 0 over here. But remember, my goal in solving for x is to get that x by itself.
Okay.
And since this is a linear inequality and I only have one term with x in it, what I'm going to do to reach that end is instead of subtracting the 1, I'm going to get rid of the term that's added to it. So I'm going to start instead by subtracting 3. And now I have negative 1x is greater than or equal to negative 2.
Okay.
Just see how that, if you had done it the other way, you could have still gotten there. It just would have given us one more step.
Okay. All right.
Now, I still want to get x alone, and it's multiplied by negative 1. So what should I do next?
Divide the 2 by the 1, the negative 2 by 1.
Right. I'm dividing both sides by negative 1. So I'm doing negative 2 divided by negative 1, negative 1x divided by negative 1. I'm actually dividing both sides by negative 1. That's how that x ends up all alone.
Okay, all right.
But remember, if I multiply or divide by a negative, what do I have to do with that inequality?
Flip the sign.
Absolutely. So my sign flips. It's now a less than or equal to. X is less than or equal to 2. So that's half of the solution.
Okay.
And then we've got this or, and we've got to deal with the other one. So if we go to the other one, what should I do first?
Take away the 4.
Exactly. Yep, you got it. So 6x is less than negative 3 minus 4. What is that, Mateo?
Negative 3 minus 4. Wouldn't that be negative 1? Or negative 3 minus 4. That'd be negative 7. My bad.
Yeah, you got it. That's okay. You
Negative
figured it out.
minus a negative.
Now this time, what are we dividing by?
6 on both sides.
6 on both sides. And 6 is a positive number, so I don't need to flip the sign.
Okay.
So x is less than -7/6. So I have x is less than or equal to 2, or x is less than -7/6. And now
Okay.
this is where we have to put this all together and give it one answer. And in order to do that, I'm going to draw it on the number line first, and then I'll combine it in interval notation. Okay?
Okay.
All right, so here's how I'm going to do this. We're going to do it in stages. Once you've done a lot of these and you get really good at them, you probably won't draw all 3 of these number lines, but you might just to be sure. So let's go ahead and do this. Okay, points in question. -7/6 is an important piece of this. Probably should be more like there. And 2 is the other piece of this. 0, 2, -7/6 is back here. And then I'm going to do one more. So this might seem like overkill, but I think you'll understand better if we draw it all out, okay?
Okay.
So x is less than or equal to 2. So if that was the only thing we had here, we would start at the 2 and we would shade everything which way?
To the right?
Less than or equal to. So which numbers are less than 2?
Oh, to the left.
To the left. So I'm going to go less than 2. Now, depending on
Oh, yeah, because it's less
what
than
book,
2,
what
right.
software, whatever, we might use a closed dot there. I think they're using the little square bracket.
Yep,
So
that's what confuses me is the square
So the
bracket.
square bracket is just the same as the old closed-in dot. It's just a different way to notate that it means include that point.
Okay.
Okay, so you're going to use that anytime your symbol is an or equal to symbol. So since that was less than or equal to, that's why we use the square bracket.
Okay, okay.
Okay? Now, that's just this one, or this one. X is less than -7/6. So that's here. And again, the old-fashioned way would be that we would use an open circle and we would shade to the left again. But since this is a newfangled way to write this in a way, we're just going to use the parenthesis.
Okay.
So the parenthesis is there because it was strictly less than. So the less than symbol and the greater than symbol get the parenthesis. The or equal to added on to it gives you the bracket.
Okay, that makes more sense.
All right, now step 3. This is kind of taking us a little bit, but we're going to get it all right, right?
Yep.
It says here or here, and or means union. So I want all of the numbers that either got included here or here. They don't have to be in both places, one or the other.
Okay.
And that's everything all the way up to 2. So there at the bottom is my final graph. Now my final answer is that notice on this graph, it's only the numbers less than or equal to 2 that got included, right?
Yep.
So we could write our final answer in inequality notation as x is less than or equal to 2. We didn't even need anything from here. This didn't contribute anything to the situation.
Okay.
If they ask for interval notation, your graph is still really helpful because you're going to read left to right. Way out here at the left end is -infinity. That's where we sort of start. It's not really a start because we can't get there.
Yep.
And then comma, where do we end? We end at 2, and the square bracket comes back again. That says include the number 2, don't leave it out.
Okay.
Does that make a little bit more sense for you?
Yep. No. Yeah, that makes a lot more sense. So.
Okay, good. Do you want to go try another one in that section? Maybe while you're there and while I'm here?
Yeah, I could do that.
Just try one more and we'll make sure you got one right.
All right, yep, that sounds good.
Before I leave and leave you on your own.
Let me just type in this one real quick, and then, yeah, that'll be helpful, so. Okay, so this one, are you ready?
Yep, I'm ready. I'm not going to
Alright.
put it up on the board yet. I'm going to type it in the chat so I have it for later.
Okay, X is greater than or less than, no, X is less than or equal to -5.
Less than or equal to -5. Okay.
And then, or X is less than or equal to -3.
Okay, so notice on this one, they're not making you do any work. They just want you to come up with the solution. So I want you, so essentially right now, you're at the point on the problem we did last, at our last spot on the board,
Okay.
right? Where we had
So-
X is less than or equal to 2 or X is less than or equal to -7/6. You're
Yep.
essentially at that same spot. So what I want you to do is draw those 3 number lines and see if you can come up with the final solution. And then tell me
Alright.
what you get before you put it in so we can get you up at least one more level in your mastery.
All right.